inequalities in the form of this is the division, and other one is the multiplication. We'll try to learn these, how the division and multiplication apply when the inequalities. Okay, so here first we look at the division part. Okay, we will have a expression just like this: x divided by y greater than 0. So what are the possibilities that satisfy this particular inequality expression? So if there are two possibilities, okay, so x can be a positive and y can be a positive value. Okay, example we can take like this: x can take 2 because x and y are both are positive, and y is also we can take 10. So that means 2 divided by 10 is also a positive value. So what are the other possibilities here? Okay, x can take a negative and y can also take a negative value. So let's take an example. X can take a negative, both are negative values. So therefore x is minus 2, y is minus 5. So therefore answer will be 2 over 5. It's also positive. So in order to satisfy this particular one, this one or this one are the answers for this particular inequality expression. So this one is finished here. So let's go to the other one. In this case, we will have x over y less than 0. So in the previous, just like the previous example, we have two possibilities here also. Another one, possibility 1, x can be a positive value and y should be a negative value. Okay, so this one O. So example, we can take x is a positive value, so we can take 2 divided by y is a negative value, we can take a minus y. Therefore this one is a negative. Rather, okay, it's the other way around, right? X can take a negative value and y can take a positive value. Examples: minus 5 divided by 10. So the answer will be minus. The answer will be negative value. So in order to satisfy this main equation, we will have answer this one or this one. Okay. So let's move on to the multiplication part. The multiplication part, we will have x multiplied by y greater than 0. So what are the possibilities here that we can write down? So here x greater than 0 and y greater than 0 is the one answer. Okay, example for this one, x can take, just we can write down like a 2 multiplied by y is also positively, therefore 10. So the total is 20, which is a greater than 0 value. So what are the other way around? Okay, x can be a negative value and y can be a negative value. Okay, so examples, uh, for the negative value, minus 2 multiplied by minus 6. So answer will be plus 12. So therefore, satisfy this equation also, these are the two solutions. Okay, these two need, this one or this one need to satisfy, not satisfy the main equation. So we have just finished this one also. Let's move to the final one. Here we will have the x multiplied by y less than 0. Here there are two possibilities that we can write here. So x greater than 0 and y less than 0. So one solution. Other one is x less than 0 and y greater than 0. Okay. Example for this one, x greater than 0 is 2 multiplied by y less than 0 is minus 1. Therefore, final answer is also negative value. Okay, here x smaller than 0 is minus 5 multiplied by y greater than is 10. Here we will get minus 50, so less than 0. So these are solutions that satisfy the infinity expression. So we have finished all the theories. Let's move to the next slide. So again, we will have some examples to solve out. First one is, here we will have x plus 1 divided by 2x minus 6 greater than 0. We need to find the x values that satisfy this main expression. Okay, so we know that this can take as k, can take as y. So here we will have k over y greater than 0. So what are the possibilities satisfy this expression? Can take like k greater than 0 and y greater than 0. Or here you can say k less than 0 and y less than 0 also. Okay, so let's move to, this is the case number 1. This is the case number 2. We will need to look at both cases to find out the answer for this particular example here. Okay, k is x plus 1. We will analyze the case 1 here. So x not in here x plus 1 greater than 0 and 2x minus 6 greater than 0. Here we will get x greater than minus 1 and x greater than 3. So we need to draw it out here. Here minus 1, here 3. Here saying x greater than minus 1 look like this and x greater than 2 means look like this. So the answer will be the common space that merge both the infinite expressions. So therefore answer will be x greater than 3. Okay, for the case 1. Next going to the case number 2. In the case number 2, this one, here x plus 1 less than 0 and the possibility 2x minus 6 less than 0 also. Here we will get x less than minus 1. Here we will get and x less than 3. So let's try to put it out here. Minus should be here, 3 should be here. Here we will have x less than minus 1 here, x less than 3 means here. So due to that the answer will be the common merge space. That means x less than minus 1. So in order to satisfy this particular expression, okay, we need to satisfy the case 1 and case 2. The case 1 and case 2 are the answers. So that satisfy the both one. Therefore we can write down the final answer look like this. Okay, the answer will become x less than minus 1 or x is greater than 3. This is the final answer. Let's see whether it is correct or wrong. As you can see, it's correct. Okay, So let's move to the example number 2. Second example is given as 2x plus 3 divided by x plus 2 less than or equal to 1. In here, we need to convert this particular main expression look like this k over y to 0. So in order to do that, we need to subtract, need to take this one value to this side. So we can do that by subtract both sides by 1. Therefore, 2x plus 3 x plus 2 minus 1 less than or equal to 1 minus 1. So therefore 2x plus 3 minus x minus 2 divided by x plus 2 less than or equal to 0. Here we will get x plus 1 over x plus 2. So now it's just as a previous example move. So in order to this happen, there are two cases need to satisfy. One is x plus 1 equals 0 and it's case 1 plus 1 greater than or equal to 0. Other one is x plus 2 less than 0. Why do I put greater than or equal? Because when the x plus 1 is greater than or equal to 0, what happens if this one is a 0? So therefore it's also 0 and it's a somewhat solution for this main expression. So that's why I have put here. Okay. So here we will get x greater than or equal to minus 1 and here we will get x less than to minus 2. So what are the common region? Here we have to mark it out, draw it out, and here minus 2 is somewhere around. Okay, sorry for that one. We cannot mark that like this, like that. Minus 2 is, we need to mark it like this. Here x greater than or equal to minus 1 will look like this, and here x smaller than minus 2. Therefore in this case 1 we don't have merging regions, therefore there is no answer for no value for this case 1 condition. Okay. So what is the case 2 condition? Okay, case 2, here x plus 1 can take less than or equal to 0 and x plus 2 greater than to 0. Here we cannot put the greater than or equal, because if this one 0, what will happen? It goes to the infinity or not defined region. So therefore that's why we have put less than or equal here only. Here we will get x less than or equal to minus 1 and x greater than to minus 2. Therefore the answer common region to this particular example minus 1 we need to mark like this, minus 2 mark into, sorry about that one. Okay, marking out. Okay, we need to draw it again. X here minus 1 will look like this, minus 2 will look like this. Here x less than or equal to minus 1 will look like this. Here x greater than to minus 2 look like this. Therefore the common region is here. Therefore the answer will be x greater than to minus 2 and less than to the minus 1, less than or equal to minus 1. In the case 1 we don't have no value, so therefore this one we have a value. So this is the answer for the given example. Okay, x greater than to minus 2 and less than or equal to minus 1. Okay, you can see that our answer is also correct with the given answer. Okay.